Hello everyone, this is 3.1 of AP Pre-Calculus, so we're going to try to look through periodic phenomena. It's a pretty big word for a really simple term, actually. You can also think of it as cycles. What do cycles do? It's like, picture a fan, maybe. Have a fan. Now, it's always going to keep spinning at the same speed, assuming that, your fan doesn't change or, it's plugged into the wall. So we're having the same speed, and at this speed, it's going to hit the same points. It's going to go, okay, at 3 seconds, we'll hit, I don't know, we'll do 4 inches from the ground. Then at, it'll consistently change. So the fact that it remains a repeating and equal length pattern is what periodic phenomena refers to. Length pattern. Repeating equal length pattern. A better word for this would be a periodic relationship. It crosses over periods that remain consistent. So let's take a look at the practice problem. Oop. Okay, you've got 3 of them here. So first, the first one's you throw a ball and its height increases by its maximum before decreasing to 0. So we're going to make the question is making graphs for this, of this periodic relationship and as to why is it. So we're going to say visualize and graph. Wait. Visualize and reason. I cannot talk and write. I understand my Spanish teacher now. So you throw a ball and its height increases to its maximum before decreasing to 0. So just picture a ball being thrown in the air for a second. You have yourself, and you have your ball. You toss it up in the air. It hits its maximum before decreasing to 0. So 0 would be the ground. Now, let's turn this into a graph for a second. So we have our axes, right? Axes. Our axis is the height, right? In this specific situation. And we have our ball's height increase and then drop. So if we were to graph that, it would look something like this. So we'll be starting at 0, assuming we're going to kick the ball, from maybe or throw it from the ground or something. And it goes up and it goes back down. Now, why is this a periodic phenomenon? Well, we don't have clear evidence as yet until why, unless we were told it. So in this case, we're being told it's periodic because we only have one cycle. We only have one occurrence where a pattern occurs. This would be several cycles, with this being the first one. That's right here. So in short, here's our visual of number 1. And our reason is that we were more directly told, but we can see that it's going to come back down to the same point it was at. As long as it consistently hits one point, or one y value, you can call it a pattern. So if you go like this, the top and the bottom points are all being hit. That's the same. These are both periodic functions. Periodic patterns. Okay, second one. Every day, the temperature reaches its low at 4 a.m. and its high at 4 p.m. So this is a weird one, so I might set it out until the end, but we'll try here. Okay. Every day, the temperature reaches its low at 4 a.m. and its high at 4 p.m. So we're going to start here and go high, low, high. And our x-axis here is time. We should have labeled the axes, but, height, time. Always keep in mind that the x-axis, when time is involved, the x-axis will equal time. So in here, time will always progress at the same rate. It will always be 1 hour, 2 hour, 3 hour here, 4 a.m., 4 p.m. So at 4 a.m., it's at its lowest. At 4 p.m., it's at its highest. at 4 a.m. It's its lowest. Now this doesn't have to be 4 a.m. It's probably it's whatever differences between these two numbers, but my point is that we can also see a consistent pattern here where these are hitting the top and these are hitting the bottom. So because we're being consistent in our intervals, which you can see at the fact form with time, and because it is repeating the same pattern where, oh, we're hitting here, we're hitting here, we're hitting here, we're hitting here. This is a periodic function as well, or periodic pattern, or a cycle. Depending on what term you want to use, it'll also be up to your teacher or math textbook. Okay, last one. You put a frozen pie in the oven and the temperature increases quickly at first. I'm going to just imagine a pizza here because maybe this is in New York. Who wrote this? These are College Board problems because it's APP calculus. Okay, let's graph this out. Okay, 3. So you put a frozen pie in the oven. So the temperature starts at 0 because, I mean, I wouldn't really imagine the temperature to be warm, assuming it's already frozen, right? And the temperature increases quickly at first. So it increases really quickly. We're hitting points. And because we're saying at first, it's going to imply it's actually going to slow down and it's increasing. So that's what this graph would look like. Essentially, quickly at first, we're going from here to here in 1 point. So that's 1, 2, 3, 4, 4, right? And then, let's see. And then we slow down because it says at first. Not just quickly, just at first. So it's only at the start where it increases quickly. Now this is not a periodic function. I tricked you. I definitely meant to do that. Why isn't this periodic? It's because this pattern isn't going to repeat. It's going to continue right now it looks like an exponential graph. It looks like it has an asymptote right here, where this point will come just close enough but never quite hit that line, which means we're never going to repeat a y value. We're never going to go back to x equals 1, or I guess y equals 1, y equals 1, y equals 0, y equals 0, y equals 0, and it never will again. So this is actually not periodic. So I hope I was able to teach you. I completely misspelled that. Wait, periodic. I hope I was able to teach you through these practice problems what you need for periodic functions. Here, we'll go back over here and we'll summarize. So for something to be a periodic function, or we'll call it pattern slash relationship slash cyclical, many different terms. For it to be that, you need it to repeat over consistent intervals. Repeat over consistent intervals, which means the x-axis, let's say 5, 10, 15, those are consistent intervals. They're all increasing by 5. However, if it was like 5, 10, and it went off into the distance, and we're going to assume that it kept, doing that would not be periodic. So that is not consistent intervals. Also, that isn't the right shape, but, So as long as it's over consistent intervals, as long as it repeats, because it's a pattern, it needs to happen more than once. So if you had, and it went on like that forever, that would also not be periodic. And, okay, I gotta double check because you have the long list here. It's really not too difficult, but also as long as it repeats or hits the same points. So if it comes back to 0, if it comes back to 0. Now it can do this several times, but it's going to have to come back and loop the pattern again. Think of checkers, like a checkered sweater. The next square, this one, has to be filled in for this to be a pattern. But if it isn't, it's the same here. If it doesn't fill in, it's not a periodic function. So we're just going to condense these into 2 points. So I hope that made sense. Thank you for watching 3.1 Periodic Phenomena for AP Pre-Calculus.